Assalamu alaikum. For this topic, we will discuss the assessment of heterogeneity of effects. So we would like to understand interaction in study, and of course to be able to identify interaction in studies, and to be able to handle, interpret, and prevent and control interaction in studies. So you can you need to not you can but you need to read this chapter, defining and assessing heterogeneity of effects interaction, in chapter 6, right, in Epidemiology Beyond the Basics, 4th edition, all right, 4th edition by Sisklo and Nito. Chapter 15 from Epidemiology book by Gordis is a much easier text, all right, much easier text. Optional, if you can read this paper, recommendations for presenting analysis of effect modification and interaction paper, right. So interaction is used in epidemiology to describe situation in which two or more risk factors modify the effect of each other with regard to the occurrence or level of a given outcome, also known as effect modification, but needs to be distinguished from confounding. What do we mean by interaction? McMahon defined interaction as when the incidence rate of disease in the presence of two or more risk factors differs from the incidence rate expected to result from their individual effects. So for the dichotomous variable, interaction means that the effect of the exposure on the outcome variable differs depending on whether or not another variable, the effect modifier, is present. In the case of continuous variable, interaction means that the effect of exposure on outcome, okay, expressed by regression coefficients, depends on the level of another variable rather than presence or absence. It depends on the level, all right. If interaction exists and the presence of the effect modifiers strengthen or accentuates, this is said to be synergistic or positive interaction. If the presence of effect modifier diminishes or eliminates the effect of the exposure, this is called as antagonistic or negative interaction. So again, the effect can be greater, positive interaction, or synergism, or lower, negative interactions, or antagonism. So you have to have a minimum of 3 factors so that you can examine the phenomenon of interaction, right. So for example, the putative risk factors is factor A, right, and then you have variable y, and you have variable z, what will happen in this kind of relationship. All right. Assessment of interaction. After observations that a statistical association exists between risk factor A and Y, and this is outcome Y, and you are sure that the association is not due to confounding, bias. So next question is there any interaction between A and Z? All right. Does the magnitude of direction of the effect of A on Y vary according to the occurrence of some other variable Z in the study population? If yes, there is interaction. Okay. For example, because diabetes is a stronger risk factor for coronary heart disease in women than in men, it can be concluded that there is interaction between gender, okay, that is, gender modifies the effect of diabetes on CHD. This is the Y variable. This is the A variable. Okay. So the conceptual framework, number 1, is there an association between risk factor X and disease Y? Right? Is it due to random variability, confounding, or bias? If it is yes, then you need to handle a random, confounding, or spurious association here. If there is no, check if the association is similar or not in subgroups of the population. So if it is yes, if it is similar, then there is no interaction. If it is not similar between levels of the covariates, then interaction is or effect modification is present. So you have additive and multiplicative interaction. In this subsection, you need to be able to detect additive interaction. Okay, so you need to read and understand the absolute difference or attributable risk model. Sorry, excuse me. Right. So this is a hypothetical example of absence of additive interaction. This is a hypothetical example of presence of additive interaction. So this is the Z, and this is the exposure variable, right? And then this is the attributable risk. So this is presence of additive interaction where the attributable risk is are different between strata of Z. So this is exhibit 6.2, detection of interaction through comparison of expected and observed joint effects This is the additive interaction. So the joint expected attributable risk 10 plus 20, you got 30. So joint observed attributable risk equal 30 over 1 over 1000, right? So you got 30 here, right? But this one, the joint expected attributable risk, you know, here is 10 plus 20. You should get 30, right? This 10 plus 20 here, you should get 30 here, but you get 50 here. So this indicates the presence of additive interaction. Okay. Similar, this one is not. Right. Multiplicative interaction is considered to be present when the relative difference in the risk of an outcome y between subject exposed and those not exposed to a particular risk factor differs or heterogeneous as a function of the third variable z. Okay. So this is the hypothetical data in additive model. This is in table 15.13 in Leon Gordy's book Epidemiology. So this is IR, incidence rate. Okay. So this one, this 3 over 3, 1, 15 over 3. Okay. 9 over 3 and 21 over 3, you got 1537. So difference in incidence rates, 3 minus 1, 2, and 7 minus 5, also 2. And this is an example of multiplicative model. You got 3, 9, 15, 45. All right. So when you calculate this one, incidence rates 1, 5, 3, 15. When you minus these two, 3 minus 1 equal 2, 15 minus 5 equal 10. So they are different. Okay, different. So this is actually multiplicative, right? If you look at the table 15.17 in Gordy's, death from lung cancer, exposure is cigarette smoking and asbestos, right? So the finding for death from lung cancer in relation to exposure, if the relationship between smoking and asbestos exposure were additive, we would expect the risk of those exposed to both smoking and asbestos to be 58.4 plus 122. Okay, this one. And then minus 11.3. You should get 169.7. Okay. Excuse me. If it is an additive interaction. But if you look here, the value is 601.6, which is much greater than the expected additive value. So this is an example of multiplicative interaction, okay, which strongly suggests synergism between asbestos exposure and smoking. So table 6.3 and table 6.4 shows the absence of multiplicative interaction and the presence of multiplicative multiplicative interaction respectively. So if you look here, the incidence rate of 10 and 20, 25 and 50, so 20 over 10 and 50 over 25, so you got 1 2 1 2, right? So this indicates the absence of multiplicative interaction, right? This one, 10 20, so 20 over 10 and 125 over 25, so you got 1 2 and 1 5. So difference in the relative risk between level indicates multiplicative interaction between Z and A. So this is another way of detecting the interaction. This is detection of interaction through the comparisons of expected and observed joint effects. Okay, multiplicative interaction. We saw it just now. Okay, so you have Z and you have A. The joint expected relative risk 2 times 3, you get 6. Right. Observe incidence rate and observe relative risk, right? 2 3 and you still got 6. Okay, so there is no multiplicative interaction. Similar here, right? But here you have a joint expected relative risk of 2 times 3, which is 6. But what you have here is the joint observed relative risk of 9, which is different from 6, bigger than 6. So this indicates multiplicative interaction. Okay. But again, the assessment of additive or multiplicative model should depend on the biology of the disease. Right. Examples of the of application: interaction between gender and diabetes. Right. Please study table 6.8. In those exposed to diabetes, both the attributable risk and the relative risk are much higher in women than in men. 6.2 versus 2.0 and 2.5 versus 1.5. Right. Where you compare the joint observed with the joint expected measures, the former, the observed joint effect, is higher than the latter, the expected joint effects. So this confirms the heterogeneity in table 6.8a. So you have two ways of accessing interaction. One is the homogeneity strategy, and the other one is comparisons of joint observed and expected effects. All right. So what you have here is relative risk of 1, 1.5, 1 and 3. Here you also have 1.5 and 2.5 there. All right. So and then you have this is the expected joint effects, and this is the observed joint effect. Right. So the next method of accessing interaction is through assessment of homogeneity of effects. Okay. this is in table 610. Study the relationship of smoking and oral contraceptive, right? So you have heavy smoking coded as no and yes, and OC use, oral contraceptive use, as no, yes, no, and yes. So this is the odds ratio of 1, this is 4.5, this is 1, and this is 5.6. Okay. So there is a bit of difference here. Okay, the odds ratio were only somewhat heterogeneous, 4.5 versus 5.6. So this might be multiplicative interaction, but not strong. Okay, a weak multiplicative interaction. And this study by Colling, asthma and idiopathic dilated cardiomyopathy, right? Is it interaction between hypertension and asthma, Z and A? So we calculate the odds ratio, 1 and 2.4, 1 and 13.4. So the odds ratio between in strata hypertension and yes are very different. So this suggests the presence of multiplicative interaction. The next method of assessment of interaction is to compare the observed and expected joint effects. Right. So in table 614, this is how you create the table. This is the Z, which is the effect modifier, and this is the oral contraceptive use A, right? And then this is the odds ratio calculated. So this is the observed odds ratio, and this is the expected odds ratio, additive and multiplicative, right? So so it is possible to estimate the expected joint odds ratio. Okay, in this case 4.5 times 7, which is this one. So you should get 4.5 times 7, which should equal 31.5, right? And when you calculate the expected joint odds ratio, you'll get 39. All right, 39. This one. So it indicates interaction if it present is weak on the multiplicative scale. All right. So this table 615, right? Multiplications of the independent odds ratio, family history of club food and maternal smoking, right? Joint expected odds ratio is 8.42. Okay, 5.81 times this one. You should get 8.42. Oops, sorry. 1.45 times 5.81, you should get 8.42. But which is much lower than the observed odds ratio, which is 21.1. Okay, 8.42 which is very much lower than 21.1. So there is a strong additive interaction and also a multiplicative interaction in the example, right? So these are the example of determining interaction. So what I want you to do is to go through the chapters in Epidemiology Beyond the Basics and also Epidemiology book by Gordis. It is not easy to understand the chapters in Epidemiology Beyond the Basics. Gordis' book provides much simpler examples of assessing heterogeneity of effects or interaction. But in terms of completeness, I think the chapter on in Epidemiology Beyond the Basics is actually is much better. Of course, you need to be able to, again, I would remind you to understand how to understand and to develop the skills on how to assess interaction. Okay, so and then you need to understand again the additive and also the multiplicative interaction, and how you would detect additive interaction, how will you detect multiplicative interaction, and how do you calculate this in a cohort study and in a case control study. All right. So for example, in the case control study, again, there are two methods of assessing interaction. Number one is through the assessment of homogeneity of effects, and number two is by comparing the observed and the expected joint effects. All right, thank you.